Hello, beautiful people. Today we're going to be talking about 9.7, and our SWABAT is factor special products. Factor special products. So you're supposed to have factored 1, 2, and 3 using the box method that you learned a couple days ago. And so for number 1, just to review it, you set up your box. You put your first term in your first box, and you put your your last term in the last box. Then you're looking for two numbers that multiply to give you a squared, b squared, and add to give you 2b. I know normally you have this in the bottom and this in the top. So what are the two things? Well, ab and ab. Because ab times ab is equal to a squared, b squared, and ab plus ab is equal to 2ab. So I put my ab and my diagonals, and then I begin to factor as you have before. So common factor here was a, common factor here was b, so I have a plus b, and then here your common factor is a, and your common factor is b, so a plus b. However, this is a special product, so instead of writing the same thing twice, a plus b and a plus b, instead we'll just write it as a plus b squared. Should look a little familiar, because in 9.3, in 9.3, you went from here to here using a special product. Same thing for here, this a squared minus b squared. You can follow my steps over here. And then for our next one, sorry about that. Same thing with the factor box. That is the absolute fine way to do it. And you can do all that work if you'd like to. Or you can learn the special products, which is what we're going to use when we do this. So one special product is a squared plus 2ab plus b squared is equal to a plus b, this quantity, squared. Again, from 9.3, you went from here to here. And so now we're going to go in the reverse order. We're going to factor instead of multiplying. So I want you to look at these. I want to make sure that you have this down. It's known as the difference of two squares, because this is a square and this is a square. Difference, we are subtracting them. And when we do, we get a minus b times a plus b. Alternatively, which means the exact same thing as this, which you can also write, you could also write this as a plus b times a minus b. No one really cares. The main thing here is making sure that when this is plus, and when this is minus, and this is minus. There are going to be some problems that will try to trick you a little bit to where it looks perfect, looks great, but it doesn't check out. And here's how you'll check yourself. You know this middle term is 2ab, so 2ab. When you check that, it should work out to where you get the right numbers. So let's check out some of these and see how we do. Okay, so the hardest thing about this, and really it's not that hard, is figuring out which pattern to use. What you're going to see me doing today is just making sure that we know what we're doing and why. So as I look at number 1, I have 36x squared minus 49. To me, this looks a lot like the sum and difference pattern, because I have two perfect squares and they are subtracting. So it's a difference of two squares. This is equal to a plus b times a minus b. Before we go on to that, let's talk about our perfect squares. Those are numbers that you can take the square root of evenly. So those come about from squaring all the numbers from 1 to as far as you want to. 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. Write this list down if you're not already. 4 squared is equal to 16. 5 squared is equal to 25. 6 squared is equal to 36. 7 squared is equal to 49. 8 squared is equal to 64. 9 squared is equal to 81. 10 squared is equal to 100. And it goes on and on and on. This is an important list, because when you start to see these numbers, I want you to start to develop an internal alert system. And it's going to go doot, 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 because every time you see one of those, an alert should go off in your mind that's telling you, I can use a special pattern. Which one? Well, if it was 3 terms, I would use a different one. But because I only have 2 terms here, I know I'm going to use the difference of 2 squares. So what squared gives you 36x squared? This next step that I'm doing right now, doing it just in the beginning. So I know that 36 is 6 times 6, so that's 6. And then x squared breaks down to x minus what squared gives you 49? 7 squared. Now I have the difference of two squares now. I can use this pattern. So this is 6x. I don't really need parentheses. Plus 7. And then 6x minus 7. That, beautiful people, is it without a box. Once you get the hang of it, this will go a lot faster and you won't be so irritated. Okay, so this one looks like a perfect square trinomial because there's 1, 2, 3 terms. So I'm just going to write it above it. Minus 2ab plus b squared equals a minus b squared. So what squared gives me 25x squared? 5x. What squared gives me 4? 2. So now I can write this just like this, and I'll have 5x. This was subtraction, so minus 2 squared. And then some of you are like, but wait a minute, what about the 2ab? I'll show you. It's 2, the a is 5x, and the b is 2. So 2 times 5 is 10. 10 times 2 is 20x. Check. And my answer is correct. Okay, let's try number 3. If you get a little bored, I know some of you guys do that. 3 and 4, you can press pause, or you can fast forward through my explanation and then make sure that you have the answer correctly done. But what squared gives me m squared? M squared. What squared gives me 81? 9 squared. The pattern I'm using for this one is a squared plus 2ab plus b squared is equal to a plus b squared. Not unlike number 2, the only difference is that because this is plus, when I write this out, this would be m plus 9 squared is my answer. The 2ab, Ms. Fitzgerald, what about that? Where does this 18m come from? Well, 2 times m times 9 is equal to 18m, so that checks out for me. Number 4 looks a lot like what we did for number 1. So go ahead and try that. You can check my work. This is 3k squared minus 4 squared. Sum and difference pattern. It's the one we wrote right up here. So I'm going to have 3k plus 4 and 3k minus 4. Again, no one cares if you put the minus first. So if you write 3k minus 4 times 3k plus 4, you're just as right as anyone else, and we still love you. Okay, number 5. The numbers are a little bit bigger. We can definitely handle them, but one thing I want you to kind of check for these is to see if there's a number that goes into all of your terms. I do this especially when numbers are a little bit bigger. So I'm looking at 100, I'm looking at 160, and I'm looking at 64. And then I break out my calculator and I try to figure out, well, what goes into all 3 of those numbers. My first hope was that it could be 16, but it's not because 16 doesn't go into 100. So I drop it down a little bit, and I think 4 goes into all 4 of these. 4. 4 times what? I'm factoring out 4. That's my greatest common factor. 4 goes into 125 times, so 25x squared, minus and minus. 4 goes into 160, hopefully 40 times, plus 4 goes into 64, 16 times. Now, you had a perfect square trinomial here, but you have easier numbers to work with here when you're doing your check especially. So when you get to these types of problems, good idea to check first. Check to see if there's a common factor that goes into all of your terms before you do anything else. So this is 4. And then what squared gives me 25? I would say that would be 5x squared, and this would be 4 squared. So this is 5x. This is subtraction, so subtraction 4 squared. And there you go. And then you can still check it. You have 2 times 5x times 4. 2 times 5 is 10. 10 times 4 is 40x. Yes, it's minus, but I didn't count for that part. So minus and minus. That's a look at your note for this section. Yes, you can use a box. Do not do that though, because these special products will come up again and again and again and again and again. If you could, please do me a favor and press pause right now as I go to your homework sheet, because there's a couple things that I want to make some changes on. So again, press pause because I don't want there to be any confusion. Okay, hopefully you have gotten this out. If not, you really do need to make these changes. So on this first assignment that says assignment number 7, where it says special product review sheet, you're not going to do that. Instead, you're going to get points just for watching this video. So if you didn't actually take notes like you're supposed to, you might want to press rewind and take them. But video notes, you will get a stamp for that. So today's date is here, and your video notes will be due on 3/18. The 18th is a Tuesday, and that's an A day instead. Also, on this day is going to be due, so this is the due date, the 18, and 3/18 will also be the due date for this assignment. So tonight, at some point over the weekend, I would like for you to do this is today's date, oops, 3/13 or 14. It's the same date as here down here. So this homework instead, assignment number 8, is going to be due on Tuesday. Both will be due on Tuesday, so be ready and have that due on Tuesday instead. So then on Tuesday, you're wondering, I know you are, what are we going to do on Tuesday instead, Ms. Fitzgerald? Instead, we're going to do 9.8. So after this 3-day weekend, we're going to do this assignment, and it'll be due on the 19th, which is also an A day. And then we will review on 3/19 instead. And then the review worksheet that I'm going to give you, which is a whole bunch of review problems to get us ready for our test, will be due on 3/20 or 3/21. Well, gee, I know you're wondering, so I'm going to tell you, if we've moved all these days up, what's going to happen here is for your test, instead of being on the 25th, it's going to be a little bit earlier, which is why you need to write this down. So your chapter 9 test instead is going to be March 20th for block 1 or March 21st for block 2. Couple of important things. So this is what I want to check on Tuesday. I want you to make sure you have this because we have moved around some dates. Look at them now, press pause if you don't have them, but make sure that you get those. Thank you so much. Thanks for joining me for another episode of Fitz TV, and I will see you later.